less worried about, coming around on a spin. Say you don't make it all the way around, you can land a little bit sideways and still slide it. And so this has been helpful, and a lot of people go by this and say that that's the best way. And my research for all these different versions of camber have brought me into the board that I designed myself, where I had to make the decision of what camber I wanted to use. Do I want the freedom of reverse camber? Do I want the power of traditional camber? Do I want to combine them and see what happens with that? And after looking at what most professionals use in competitions, I decided that traditional camber would be the best. It's been the longest lasting one, it's the most trusted, most people use it. So I thought that it would be the best because of the power you need and the speed you need for a competition board. So in after camber, the next main thing is side cuts. A side cut is a radial surface on the edge of the board based off of a circle. So for this little small picture board, it said that the middle of the circle would be 25 feet away. So that allows you, if you were turning, you could turn a perfect 25 or 50-foot diameter circle. And so there's a lot of different side cuts which I had to choose between. Do I want just based off of one circle? Do I want 3 circles blended together and multi-radial? Do I want magnet traction, which is, if you look at this picture on the bottom left, it's a wavy edge, which allows you to get a lot of kind of contact on ice because it's like a saw going into the ice. Do I want to use, grip tech, which adds a contact point by the bindings to make the board easier to turn? Or do I want this thing up on the right called Brockalizer, which is 3 straight lines, not even based off of a circle? I looked at all the benefits of these, and I realized that all of these kind of, besides for traditional, were making up for reverse camber boards. And I said, well, if I choose a traditional camber board, then all I need is the traditional radial side cut. And they go together well hand in hand, so I chose traditional radial side cut. And then you get into the materials of a snowboard. There are snowboards today that, there's one, it's a $1,000 snowboard made of completely carbon. What do I want the core, or the guts of the snowboard made out of, really? The core is what the snowboard's based off of. As you can see, these pieces of wood, these are pictures I took up where my board was made in Portland, Maine, at a factory called Team 8, who made custom snowboards. And so these cores, how a board is made is they put these cores into this computer numerical control, or CNC machine. And this machine is really helpful because they don't make an error, because they put all of the data into the machine and it cuts it for them. And so they have everything specifically tuned to what they need the board to be. And then a board is cut and it's made into this. And this picture on the right is what Burton uses in their cores. They call it dragonfly construction. And it kind of shows the difference between Team 8 using pure one piece of wood vertically and a few horizontally versus all these different kinds of wood glued together to make a kind of Frankenstein board, I would call it. Because it's not natural, it's not the way I would like to see a board made. Where all these different pieces of wood are connected are weak spots, whereas if you have one piece of wood, which is a more expensive way to make a board, then it's much stronger because there's no joints where 2 pieces of wood are connected. And so, luckily for me, Team 8 uses just pure one piece of wood vertically, so it gives it a much smoother feel because, everything's even. And so, after the core is cut in the CNC machine, they have to lay up the base and edges. The base is made of what we call PTEX. It's high molecular plastic, and there's 2 kinds of it. There's an extruded, which is much stronger, but it doesn't take any wax. It's very slow. It's for people who mainly want to take care of it. Or there's sintered base, which is porous like your skin. It absorbs a lot of wax and it goes really fast. And so they use sintered bases, and then they have to attach the edge. And it was funny, when I was at their factory, I went near the bases and he told me to stay away from them because if you get, a little bit of dust on the base, they're extremely hard to glue onto the rest of the board. That's what makes them so fast. But at the same time, if I got a little bit of oil from my hand on it, the board wouldn't glue together properly. And so I thought that was really interesting. And then, after they get the base, they have to get the fiberglass between the base and the core, which I have a picture coming up soon. And the fiberglass helps with the flex of the snowboard because it makes the board much stronger and it gives it a snappy feel. It responds very quickly. And then they glue everything together and they put it in a vacuum press, which it puts tons of pressure on the board during the finalization of the gluing process, as well as there's an insert that goes in the bottom of the press right here, which presses the shape of the snowboard. This one's set up for a camber snowboard because it goes up a little bit, and underneath the machine they had an insert for a reverse camber snowboard, if that's what I wanted to use. And so now I have a quick video from Burton Snowboards in their factory in Vermont, and it shows a 2-minute clip of the process of making a snowboard and how the main steps of making a snowboard is easy, and then there's a cleanup process at the end. And when I was in Teammate's factory, they said, the devil's in the details, because you have to clean up, you have to cut all the excess materials off, and that's the hard part because they're still doing that by hand.
It still is a very artisans-based, handmade process. Boards are still made in individual pieces by people that have been doing it for a long time. Our construction is what we call a sandwich construction. And the very first thing that we throw into the board is the bottom sheet. And then the edge goes in. That material right there is called gummy. It moves with the board so that when the board is being flexed, all the materials inside of it can shear just a little bit on each other, and that holds the board together. And we have a carbon glass on the bottom. Seems all loose and flexible and everything right now, but boy, when it cures in the mold, it becomes just this really poppy spring. So the core goes in. We have engineered these cores to make the boards really snappy, light, they spin, and they just pop underfoot. Once the top sheet goes on, then the sandwich is really complete. These are all things that we've learned working with engineers, working with our team riders to come up with ways to make the boards ride better for them.
So that video shows really well the whole process of making the board, and it also showed the core that Burton uses that I said is the Frankenstein core. It's kind of a grotesque way of making a core for a snowboard because they're not using natural components. They're putting all these pieces of wood together to make something that they think is the best. And after riding many Burton boards, they actually do ride very well. But just looking at that, I personally think that it's kind of a gross way to make a snowboard. And also, I just want to say that at the beginning when they were spraying the base, they were spraying that with air to make sure there was nothing on it during the gluing process, because like I said, what makes a base fast is the fact that it sticks to nothing. So if there's something between the base and the glue, then it really won't stick, and it'll be difficult to, they'll have to make a new snowboard altogether. And so now, after doing all this research, I got into my board and what I wanted to use in it and what Team 8 could offer me. And so I get into my board's materials. So the base, like I said, we used PTEX, which is ultra-high molecular weight polyethylene. That's why they call it PTEX, because it's much simpler to just say that. And the core is one of those, perfect one piece of wood all the way down cores made of poplar wood with maple stringers, which is, horizontally every few pieces of wood they put a piece of maple wood down, which is stronger and lighter, but it's also more expensive, which is why they don't make the whole board out of it. And then the glass weave. They use fiberglass in snowboards between the base and the core. And what this, like I said, it adds strength and energy to the board. And so this is kind of a diagram of the fiberglass weave. It's two pieces of fiberglass crossing their fiberglass threads, and then they have a carbon thread going up the middle. And so the fiberglass adds strength, and the carbon reduces weight while keeping the strength up. So they really do a lot to kind of keep the weight of the snowboard down, because if it's too heavy, you can't move the board at all. And then I get into the specifications of my board. It's, like I said, a regular camber snowboard, regular radial side cut, because getting into the reverse camber and multiple side cuts, it just seemed like there's one thing you can trust, that's traditional camber, traditional